This is a Total production.
Hello everyone, welcome back surveyors. This is going to be our third practice video for chapter 4. And so for this we're still practicing ionic namings, but now I've thrown in polyatomic ions. Every single one of these has a polyatomic ion. And so what you want to make sure is based off the slide in our chapter 4 PowerPoint right here, what is labeled for this PowerPoint currently as slide 87, right? This has the list of all the polyatomic ions that I feel you should know. All right, and so here's just practicing naming with a few of these. All right, so firstly, let's look what we got here. We have K, which is potassium, and then CO3. So that right here is carbonate. All right, so potassium, in naming it, potassium, all right, carbonate. All right, and what we can tell here is with this carbonate, right, potassium has a +1, and the carbonate ion itself should have a -2, right? That's why there's 2 potassiums for 1 carbonate ion. Polyatomic ion. All right, next up we have Mg, and then in parentheses this polyatomic ion. This is called acetate. All right, and acetate here, magnesium from the periodic table has a +2 charge. The acetate, each one has a -1. So that's where there's 2 of those polyatomic ions. So we would call this magnesium acetate, like so. All right. Next up we have nickel. Nickel is a polyatomic ion. So I'm not just going to write nickel, I'm also going to need parentheses where I put the charge of the nickel ion. So to do that, we have to look at this polyatomic ion right here, NO3. This is called nitrate. All right? And so you don't just need to know the formula and the name, you need to know the charge associated with a nitrate. And each one of them is -1. So there's 2 of them. So you have a total of -2 on this side. So to be neutral, the nickel has to be a +2. So I need to write a Roman numeral 2 in those parentheses. All right, next up, I got to put the name nitrate. All right, like so. All right, next up we have a metal calcium. All right, and then PO4, that there's only one polyatomic ion with phosphorus in it. No, well, there's 3, but it's phosphate, it's hydrogen phosphate, and it's dihydrogen phosphate, so they all have the PO4 in it. But this one, since it doesn't have hydrogens in front of this phosphorus, this is just phosphate. All right, like so. And next up we have iron. Iron is a transition metal. So like nickel, I'm going to need parentheses with the Roman numeral. And so to figure out the charge to put here, I have to look at this OH. This is called hydroxide. So I have iron hydroxide. Each hydroxide is a -1, but there's 3 of them. So that means iron, so I've got a -3 charge, and iron has to balance that out to 0, so it should be a +3 iron. So I need a Roman numeral 3 in there. All right, now the real fun begins. Here we have ammonium nitrite. So nitrite is similar to nitrate. Nitrite is NO2 with a -1 charge, and then ammonium is NH4 with a +1 charge. So you notice there's 2 polyatomic ions coming together. So here we have a +1, here we have a -1. So it's really just 1 and 1, one of each. So NH4, NO3, and that's our ammonium nitrate formula. Oh no, I did nitrate. It's supposed to be nitrite. Can you tell I like nitrate over nitrite? Anyway, so next up we have aluminum hydrogen sulfate. All right, so hydrogen sulfate is HSO4 minus. All right, while aluminum, right, based off the periodic table, where is my periodic table? Oh, here it is. And so aluminum, based off the periodic table, is in this column. That's a +3 column. So that means I've got a +3 and a -1, so I've got too many plus charges. So that means I'm actually going to need 3 of those guys so that I get a -3 and a +3 come together. So the formula should be Al HSO4 3, like so. So that would be the formula for aluminum hydrogen sulfate. Next up, we have sodium permanganate. Sodium's easy. That's Na+. Now, permanganate is weird. It's got like a manganese and an oxygen, so it's actually MnO4, and it has a -1 charge. So you notice plus a positive one, a -1. So I really only need one of each to get a neutral compound out of here. So I'm looking at NaMnO4, and there's my sodium permanganate. All right, next up, I've got lithium oxalate. Lithium, right, is right here in the first column. So that's going to be lithium +1. And then oxalate is like a carbon-oxygen combo. It's like C2O4. And oxalate has a -2 charge. Okay, so you notice I can't just have one oxalate and one lithium because I would get an overall negative charge. So that means I actually need two of those to balance. I get a +2, a -2, and they would be balanced. So I'm looking at Li2 C2O4, and that would give me my lithium oxalate formula. All right, now we finally appear to have a transition metal. We have cobalt-3 bicarbonate. So cobalt is CO, and based off that 3, we know it's a +3. Next, we have bicarbonate. Bicarbonate is like carbonate, but it has a hydrogen with it. So that's going to be HCO3. And it has a -1 charge. So let's look. +3, -1. I don't have enough negative to neutralize and get a 0 charge out. So I'm actually going to need 3 of those, right? That'd give me a -3 and a +3. They come together and give me 0. So I'm looking at CO, HCO3, 3, like so. All right, so this is not exhaustive. This isn't all of them, but it is the majority of those polyatomic ions that you need to know. So hopefully this was fair practice, good to kind of get you going with those 14. There's really only 4 we didn't cover. So, all right, well, as always, until next time, stay weird. Adios, surveyors.